Hi everyone, and today we'll make our ML project from zero to hero, from dataset to MVP in just 15 to 20 minutes, I think. And here is our data. It's breast cancer data. So let's assume we want to make an ML product for clinics which are diagnosis breast cancer, and we want to make their job easier and faster. So let's assume that all those data they can get from the laboratory, and for each of those measures we have 32 measures here. So for each of those measures we need for example 1 day, and after that our doctors will need also from 2 to 3 days to analyze it and to get the diagnosis. And if it is here M, which is malignant, it's a very bad diagnosis, and for betting it's okay. So we need to understand fast enough which of those diagnoses they have, and the situation right now is the following. So we need to wait for 1 month to analyze all those measures, and after that we will need to wait for 3 days for our doctors to analyze the data from laboratories and to get the diagnosis. So the first idea is that we can try to build an ML solution which will analyze all those data automatically and get the diagnosis. And if the diagnosis is this M, this malignant, so we will need to contact doctor as soon as possible and try to save our patient life. So we can make this ML solution and use maybe nurses or something like that to just put all this data to our solution and got the diagnosis. So we don't need these 2 to 3 days to wait for a doctor to have time to analyze all of that. And let's try to do that. And we have this data. It is here. I just downloaded it here, and I have my fast benchmark app, which is from fast benchmark bot. You can visit this fastbenchmark.me and get this bot, and on fast benchmark site you can find all those instructions of how to get an app and how to work with that. And in this video I will just work with that app. So we opened fast benchmark, it's here, and we have a data and we have an app. So let's run the app and let's find our data. It's here, and what we need to predict, we need to predict the diagnosis. And let's remove on all useless variables. This one is for RON CSV format, and this one is ID. We don't need an ID. Okay, so we'll use it like that. So we need to generate structure, look at the structure. So once again, it's just a structure of your data, no data itself, so you don't need to send your data, you need to send only the structure. Okay, so we will send this structure and got the report with prediction. Don't worry about the names here, it will the app will fix it. So we can now view report and run it, and we can see how our data looks like, how our target variable looks like, and how all other variables looks like in terms of our target variable. So we can look at all those data that will help us to make some feature generation if we need, to tune models if we need, and so on. And we got this prediction here. It has a very good score, so the almost perfect here. So that means that we really can use some not very professional personnel to analyze this data. We need just somebody who will take the data from here, these points, and will just provide it to our model, and we will get the prediction very fast. And let's look at this again, and this is for our full test set. It's almost perfect also, and here we can generate some new variables, but here we don't need it because we have a very good solution from scratch. And here we can specify if we want to tune categories or tune our model to try different model settings and maybe make our prediction better, but in that case we don't need it. It's all our final prediction is like that. So let's look at the data again and think of it a little bit different. So we know that each of those measures we can take after 1 day of laboratory working. So all of those we will take after 32 days, but maybe we can just limit it to maybe 4 or 5 variables to get the diagnosis after just 1 week or just 5 days or something like that. And let's look at the feature importance, which we also got here thanks to our fast benchmark. And here we can see that actually the most important variables are those 5. So let's try to make a prediction based on only those 5. So we can ask the laboratory to give us only those 5 variables, and it will be very fast. It will be just 5 days, and after these 5 days we will see the diagnosis, not after 1 month but only after 5 days. That's really cool. So let's try if we can do that. So for that purpose we need to configure our variables here, and we need to left only those 5 variables. So we don't need this, don't need this, don't need, I see the need mean only for concave points. So okay, so we don't need all of that, but we need this one. And for SE, which is standard error, we need only area. So let's take this area, that's this one. So we don't need a standard error for anything else. Okay. And for worst we need texture, area, and concave points. So okay, so we have texture, we have area, and we have concave points, and we don't need anything else. Okay, so let's save and close and generate structure again, and we can close this one and back to our app and look at the folder, and we'll send it to the bot. Okay, and they got a new report, and let's look at this new report, which is based on only 5 variables, and let's run it. So first we have all the variables, and after we drop some we have only those variables. And here is a very beautiful plot which is explaining us how all those variables here are connected to each other in terms of our target variable. So we can see that we it's for sure we can build a pretty good model here. So let's look how FastBenchmark did it, how it's handled it, and let's look at the prediction score, and it's pretty good. And again, we can try to tune something if we don't have such a good prediction, but here we don't need to tune or to engineer to make some new features. We don't need all of that. We can just use it as it is, and we'll try it. So now we have this. Let me show you again. Only these 5 things that we have to provide to our model to get the prediction, and that will be a very good prediction. So let's assume that we ask our laboratory only for those 5 parameters, and we are using someone who will just take those values and put it into our model and get the prediction. And if the prediction is M, he will go to the doctor and will say that, oh my god, it's the prediction is and it is malignant, and we need to do something to our patient to save him. And doctor will analyze this one again, and he will say, oh yes, that's a big problem. Or maybe he will say, oh, maybe that's a mistake of your algorithm or something like that. But anyway, he can react at that case very fast after 5 years, not after 1 month. So okay, but how can we make this prediction usable for someone in our clinic, or maybe clinics, if we want multiple clinics to be our clients? So that's very easy with FastBenchmark, because FastBenchmark can make a service out of your model, and also it can make a UI for that service. It will be a Telegram bot. So let's do that. So we need just to generate service structure, and also we can look at that at our folder. So what we see here is the code which we are using in our feature engineering, in our working with our variables, with NaN values and so on. So if we will change something in this report, as you can see here, we can open the code and we can correct it if we want. So all those things are here. So no data, just some parts of code, nothing else. And this is the only thing we need to send to the bot to get the generated service and Telegram bot. Okay, so we'll send it. Sorry, here, and the bot here. So let's send it to the bot, and we got the service and its documentation, so we can look at the documentation from here, and that's how it looks like. And we also can look at the documentation if you don't have any add-ons on your browser to look at the documentation. You can look at that out of the app. So it would use JupyterLab to show you that, and you can use this markdown preview and you will see the documentation. Okay, so what is the documentation? It's about which data you have to provide to your service, which are the answers, and also how to start your service and how to use it from your code. And here is the example of Telegram bot. But if you will use an app, you don't need all of these. You can just start your bot on a local host, and you can generate a bot out of the app. So you actually don't need to copy and paste something from here and to write any code. So you can close this, and right now you can just start service, and as it started you can configure your bot. So you need here to specify equations for each measure, so it will be easier for someone who will provide the data to our service to answer those questions. So we can take it from the description, from the data description. So let's just select only the columns we need. So we of course need diagnosis, and what else? Let me see. Concave mean, area SE, and after that worth. Okay, so concave points mean, area SE, and this texture worst, this area worst, and this concave point worst. And let's check this all. Yes, that's all we need. Apply, and we have this description. Okay, so we just put the text, explanation text here, and for area it's just a standard error. It's a standard error for cell area. So it's an area of the cells which we have in analysis, and this is texture worst. We have a text here. Okay, and the area worst is the worst to largest. Worst is always worst to largest. Cell area, and for concave points we have this. Okay, we are done here. So let's do this like that, so it will be easier to understand. And here we got the prediction with probability, and we can add some math here in those quotes, but outside of these quotes we can add only text. And let's add some description here so we know what is M and what is P. It's here, and we will provide it to our operators. Okay, and save and close, and back to up. And if we want to start bot, we need to give a token to our bot. It's a very easy task. We can go to this guy bot father, and I have a test prediction bot, and I will take its its token. And if you want to make new bot, you can use this command, and very easily you will make new bot, and it will also give you a token. So let's take this one, put it here, and we can start bot now. And here is our test prediction bot, and here's our questions. So we can just take someone from here. You can see maybe this one. Okay, so let's take this guy. That's not a guy actually, but no problem. Okay, so let's take, sorry, okay, let's like this, and let's go. So the value here is like this, and for standard error it's like here, and 2998, and this one, and also 0.1767. okay, and we got the prediction here. So the prediction is M, like in our dataset, so that's a very bad diagnosis. So let's assume we got this data after 5 days, and some operator, for example nurse, just put all those data to the bot and got this prediction. So she should run to the doctor and ask him to give more attention for that exactly patient, and maybe that will save that patient's life, and for sure it will save its patient's health. So that is how fast benchmark works. We just in 20 or so minutes we build a full ML ML solution, and it's MVP, and we can take this bot and just share it with our potential clients, our clinics, and they can start using it right now. So you can check if your solution is useful for them, if they will use your solution or not, and if they will, you can develop it further. But to test your hypothesis that that solution is useful, you need only 20 minutes, less than half an hour actually. And that is the main idea of fast benchmark. So you can make your data science, your ML projects very fast. You can test your hypothesis very fast, and that's it. So make data science fun again, use fast benchmark, and bye bye.